Imagine investing thousands of dollars into a fish farm, only to wake up one morning to floating fish, a devastating outbreak that wipes out months of effort overnight. This story is not unique. Around the world, farmers lose billions each year because of aquatic animal diseases. In fact, disease is now considered the single biggest constraint to aquaculture production. But here's the good news: science is fighting back. Today, we'll explore how advances in aquatic animal health management, from cutting-edge diagnostics like PCR and LAMP, to innovative tools like egg yolk antibodies and biobarcode assays, are transforming aquaculture into a safer, more sustainable, and profitable industry. I'm your host, and in this session, we'll dive deep into the exciting world of fish disease management, where biology meets technology and prevention means profit. By 2025, global seafood demand is expected to exceed wild fisheries by 55 million tons. Aquaculture is the only way to fill that gap. But diseases derail this progress. Viral diseases like koi herpes virus in carp, bacterial infections like streptococcus in tilapia, and shrimp diseases like white spot syndrome virus have caused billions in global losses. Factors making diseases worse: intensification of farming, global movement of brood stock, climate change stressing animals, and poor biosecurity with irresponsible antibiotic use. Let's understand the foundation of diagnostics. Level 1. Field observation. Farmers and technicians observing behavior, water quality, growth signs. Example: a farmer notices tilapia swimming in circles and gasping. Immediate red flag. Level 2. Lab techniques. Parasitology, bacteriology, mycology, histopathology. Example: Giemsa staining of gills to detect trichodina. Level 3. Advanced molecular biology. Virology, immunology, electron microscopy, PCR, and beyond. Example: real-time PCR detecting KHV within hours. Traditional methods like bacterial culture and histology are still essential, but they're time-consuming, taking days, sometimes inconclusive, and not sensitive enough for subclinical infections. Carriers with no visible signs. Here come the game changers. PCR amplifies DNA, even from tiny samples. Real-time PCR adds quantification, measuring viral load in real time. Example: salmon farms in Norway detect infectious salmon anemia virus early, allowing culling before it spreads. LAMP technology is revolutionary. Unlike PCR, it doesn't need expensive thermal cyclers. It works at one temperature, amplifies DNA a billionfold in under an hour, can detect as few as 6 DNA copies. Example: detecting WSSV in shrimp at the farm before mortality begins. It's cheap, fast, and farmer-friendly. Lateral flow kits work like pregnancy tests for fish diseases. Farmers can dip, wait 5-10 minutes, and get a result. Blue Spot uses vertical filtration to concentrate pathogens for ultra-rapid detection. Biobarcode assay uses nanoparticles with zeptomolar sensitivity, 1,000,000 times more sensitive than ELISA. Prevention is better than cure. Conventional vaccines are widely used in salmon and trout. Example: vaccines against furunculosis reduced antibiotic use in Norwegian salmon farms by 99%. DNA vaccines stimulate long-lasting immunity and are already approved in Canada for salmon. Egg yolk antibodies represent a breakthrough. Chickens produce antibodies in egg yolks with 18 times higher yield than rabbit antibodies. Non-invasive, collect eggs, not blood. Rainbow trout protected from Yersinia ricari with IGY feed. Shrimp and crayfish protected from WSSV using IGY in immersion baths. Science only matters if it reaches the farm. Rapid on-farm diagnostics allow farmers to separate or cull stocks early. Vaccination campaigns protect against recurring bacterial outbreaks. IGY and probiotics offer alternatives to antibiotics, aligning with consumer demand for chemical-free fish. The future brings AI plus diagnostics. Machine learning models predicting outbreaks from water quality and behavior data. Portable nanotech kits. Handheld devices reading disease DNA at the pond in real time. Global biosecurity networks. Shared surveillance data preventing cross-border spread. Disease is not just a biological problem. It's an economic one, a social one, and even a food security issue. But advances in aquatic animal health management are giving us powerful new tools: faster diagnostics, smarter vaccines, and safer immunotherapies. If aquaculture is to meet global seafood demand, the battle will not just be fought with feed and water quality, but with diagnostics, prevention, and resilience. And as farmers, scientists, and policymakers, the responsibility is ours. to build an aquaculture industry where healthy fish mean healthy communities and healthy economies.